Okay, so for the recording sake, welcome team. So just a quick recap of what we have learned in the bootcamp so far, starting with Haima has rightly mentioned the order of events or order of the learnings that we had, uh, prompt engineering, LLMs, how LLMs work, embedding models, vector databases, RAG, all of these concepts that we have, learned, and then we have built some RAG applications. So that's what we have been done so far. Now, as we said, due to the limitations of LLM, we introduced the RAG to augment the information, organizational or personal context and information to give it to the LLM to use uh, to generate a response based on that. And then if you want to give more resources for it to do a task, okay, it is limited because RAG, we had only one vector database and we're giving it to LLM. Now, what if we had multiple sources that I want the system to use to do a task? Okay, so let's say I'm a finance advisor, okay, and a customer comes to me and I have to advise him on a particular stock that he wants to invest on. What is the current good stock? So I cannot just go and search a table and give him information, right? So what will I do? I will do research. So I will first go and check what is the current price. I will check the history of that stock. Then I will check what are the latest trends and news about that stock. How we are, how is the market sentiment? So I have to consider all of these to answer the question, right? So the overall goal is to suggest or advise the customer, right? And then to reach that goal, I have to break it down into tasks. Like, I want to research the history, I want to get the latest news, I want to study the market trends, and all of these. So each is individual tasks. Now, to do this tasks, I might need different tools. Okay. For example, if I want to search for a stock, performance, I might go to Yahoo Finance, or I might go to any of those finance tools or any of the engines that are available to get the information. For the history or the current price, I might go to some website, to check that. For the market trends, I might go to local news, CNBC, or whatever is giving the finance. So there are different kinds of tools that I would go to accomplish the task. So in the same way, an AI agent is basically doing something on your behalf to achieve a set goal. It can independently, autonomously decide on the tasks and the tools it has to use to achieve the goal, to perform the given job. So that's what, in a nutshell, an AI agent means. Okay. So AI agent can be your digital, say, service agent. Okay. Suppose you have a travel agent. So an AI agent can be a digital equivalent of the travel agent. So an AI agent can do all of those things that a travel agent can do, for example. So customer can chat with the travel agent and then say, I want to book a cruise, or I want to book a vacation, or I want to book a hotel. So whatever the travel agent does, say, for example, or you are doing online on your own using multiple tools. So first thing, you have to figure out where is the location. Then you have to figure out what are all the available hotels, what is the availability, and what is your specification, what you need, what is the price, budget, and then you go to site of that particular hotel, and then you provide your details, your card, and all of this, and or at least just give your details or block it for the reservation. Same thing if you want to cruise, you got to figure out where you want to go, options, figure out what are the cruises available, what are the prices, what is your preference on the cruise, how much you're willing to pay. So all of these inputs, and the agent can actually go search all available options and then go and book a cruise for you. So as we see foresee, right? So in the future, agent can be your complete department, can be an agent. Okay, so it can do tasks on your behalf, provided you give them the required tools, and then it can autonomously, independently decide what to use, how to use. Right. So that's what, in a nutshell, the agent means. And future is all going to be agents, not just the RAG. RAG will be one part of the entire RAG you have seen. Whatever you build will become just one tool for the agent to use, right? Now you zoom out, the entire RAG becomes one of the whole picture, one component of the whole picture. So that is one part of it, one tool. And then you can have multiple other tools that agent can use. Okay. Now, see, what is agentic AI? It refers to AI systems designed to exhibit autonomy, proactive decision making, and directed behavior to solve complex problems. So it can operate with minimal human intervention. So it can automatically, it can decide, and based on its intelligence, it can take a decision as to how to proceed, what is the plan, what is the flow, which tools you have to use for which task, and all of that. It initiates actions based on context and goals, based on the context you give, based on the goal you give. And it can learn and evolve in dynamic environment. That is basically the source of AI, right? So anybody tell me what this is, what we are looking at here?
RAG
Anshu, what we are
framework.
looking at here? Yeah, Hima?
RAG framework.
Yeah, RAG framework, right? So this entire thing we know, this is a RAG framework. We have documents split into chunks, embedding model, put it in vector database. We have a user query that's coming in, embedding model used. We send the query and the context both retrieved in a prompt template to LLM. LLM will generate the response. So this is all part of the RAG. Now put an agent in the RAG. Okay. So if you're replacing the RAG, that LLM part here, this is an agent. Now, when you have an agent, so agent can have a role. So you can give it a role with the agent. So what are the components here? It's an LLM. Okay. And it can have memory, short term, long term. We'll talk about what is short term, long term. Planning, it can do a plan based on the inputs and based on the tools available. What is the goal that you need to achieve? Okay. Um, then it has tools. Okay. Now, an agent, it can have a role. So, what is the role that you are giving an agent? For example, I said, hey, you are a travel agent. You are supposed to assist the customer in booking the hotels in a particular location, right? So, the task, again, you can give in description. The customer will provide whatever information. You have to do research, find out the all the hotels in that particular location, come up with a best option or best price, and then do the booking, right? So this kind of tasks that you give, you can have multiple tasks again. And then what are the tools available? So here we say the entire this thing RAG part of it, vector database, RAG, vector, everything, it can be one tool available to the agent. So when it wants to get information from your company, so it can use this tool, vector search engine, which can get RAG from your collection, whatever you have. So this is the entire RAG vector database collection that you are using it as a tool to get the information to the agent. Calculator can be one tool that you can use. Web search, if you want to get a new, if you want to search what is the latest on the web, internet, you can give a web search tool. Mail, if you want to send out, you can give a Gmail tool. So these are all created as tools that can be used in the frameworks. and then that you can give it to an agent so it can use the Gmail to send out an emails or Slack to send out the messages. So the various tools. So basically, this is where it's going to expand. Everything in the world, everything a task, everything can be created as a tool and then provided to an agent, right? Memory here talks about short term, long term. Short term is when you are executing the engine agent for a particular task, whatever information that is flowing within that execution is short term. So basically, let's say I'm using vector search and web search. Okay. So it says, let's go to vector search and gets back some information. And then when it goes to web search for the next task and comes back, it should remember what it has got from the vector search. So that's the short term memory so that it can use both and then use another tool if you want to send out an email. Long term is over the time you are using this agent to perform this task. It learns based on the input and feedback that it is doing that research analysis. So it learns itself. So that is your long term memory. So planning, reflection, these are all just tasks, how the agent plans which tool to use or the sequence of how we are sending the information is that part of the planning. Okay. So these are the main components of the agentic AI. Now, if you see here, the same agent is now a retrieval agent. Then query, when you send a query, it's a still RAG, but with an agent. So the agent can decide whether it wants to use a vector search engine A or vector search engine B. As I said, like, let's say there is a relational data here. If it needs that relational data, it can go here. If it is unstructured data like a document or image, you are saying there is another vector database, another RAG implementation, another vector store, that tool which can connect to a different vector store and get you information. So these are two different vector stores, or maybe same vector store but different collections. We have seen, right? So you can have multiple collections. So that you can use it here. And the agent can decide which one to, or if it is a query, it can do with a calculator. So it can go use the calculator instead of going to do the RAG. Or if it is a current information that is available on the web that it has to get, it can use the web search tool. So any of these tools it can use to retrieve the information. Now, once you retrieve the information, there is another LLM. See here, this LLM is used as an agent. So every agent will also have an LLM as its brain. Now, the input that this agent receives, it's a raw input. We are not going to summarize or beautify the content and the context. We are using this LLM only to make a decision of which tool to use and get that information back and pass it to another LLM. Now, this will do your form generating the response based on the information flowing from this agent. So this is an agent, this is an LLM. So basically, even the agent will be an LLM. It has an LLM, but again, it will have the tools and then it will have the tasks and all of that as part when it is an agent. When it is an LLM, it will just take a query, a prompt, and then give you the response. Got it? Any questions here? Anshu?
No.
Murali, any questions?
No, Arun, yeah.
Pawan? Okay.
No, sir. I mean,
So yeah, just look at this. Now, we said there is an agent, right? Now we can have a multiple agents, not just one agent. So your system can have multi-agent rack, same system with multiple agents. Now, each agent, they can actually do the work themselves or they can delegate the work to another agent. Okay. So it's just like, just think of it, agent as, some people in the department are a manager or a worker, right? So they can do the job themselves or they can delegate to one of their team members. And they go and do the job and then come back. You take it and then you give it to somebody else. The same thing here. So you get a retrieval agent. It makes a decision to pass it to different agents. So which agent I can use. Okay, so this agent has again these tools. So again, this makes a decision to go to this one of these vector databases to retrieve the answers. If this agent is called, it will go get the web search. If this agent is calling, it has the communication. So basically, you're dividing as web search agent, retrieval agent, and the communication agent, for example. So which one you want to call based on the inputs. Then final, then you can say, I'm sending it to LLM to provide the response. Okay, so this is your multi-agentic RAG. So as we discussed, what do we have in this? So every RAG, every agentic application, an agent will have a profile, right? So what is the profile that contains? You give the strategy for the LLM, and what is its role? What is it supposed to do? Then you have the memory, as we discussed. There are different memory and memory operation, lang formats that it can store its memory and all of that. Planning, how it plans your task, breakdown of the task, and then gives you, sends it to multiple agents or tools to get back the information. So that is your final action. That it can do exploration, recollection, feedback, all of this. Okay, so this is just one of the kind of model or framework that they talk about. It's not a rule or something that every agent has to go through like this. Okay, so when I talk about framework, right? So there are different frameworks that we use for agentic AI. LangChain, we already using it for RAG. So LLMs and RAG support. We can also use it for the agent, to create an agent. So LangFlow, we will see today. It's a no-code AI workflow design. It's a visual interface, drag and drop each widget. I think we have earlier seen the UI ones. So that's the visual interface. Another one is LangGraph, multi-agent orchestration that you can do, graph-based execution and parallel workforce. Crew AI is one, team-based, so role-based AI agents, as I was talking about. So these are all different workflows where you can create agents. So you can also use Bedrock to create agents. You can also use LangFlow, LangGraph, Crew AI, AutoGen. So there are so many frameworks that are coming up that you can use to create the agentic AI. So we will touch one more framework called Phidata. So we can use that Phidata platform or framework to create an agent. We will also check the LangFlow, how to create a no-code visual interface with the agentic AI. Okay, so that's all the theory part. Any questions before we go and check the action, the demo?
So all these enhancements that we are doing,
Hmm?
this is to augment the query part with the context, right? And loading the knowledge base is same before calling the LLM, right?
Yeah, that's right. The context. But see, it's not just getting you the response, it's actually completing the action. See, the example we talked about, let's say booking a hotel is the goal. Okay. By the time you get the response, it's not just giving you information, it's acting on your behalf. By the time you get the response, you should actually get back a reservation ID for you. That's the goal, basically. That's how your agentic AI should work. So it has to perform an action on your behalf, not just get information. So it's not like you go, hey, I want to go to Bahamas. It cannot just go and get you information of all the cruises and throw at you. So these are all things that you take care of. It's the next level where it acts on your behalf. Okay, it should actually, if you want it to book, it should actually go to the website of that whatever cruise line, check for the cruises, take the information, input your information, and at least block a reservation if not payment, and then get you a reservation ID. Go to a hotel, find out the rooms, check in, log into that website, put in information, and then get you the reservation ID. So it's not getting you just the information, it should also act on your behalf and achieve the goal. So that's where ultimate goal of agentic AI.
Okay. So
Okay. And it should be able to use different tools and make decision as to which tool it has to use based on your input. So if you give, say, book a hotel, so it has to do the research first. So it can go to a website, travel website, to do the research, find a hotel, then go to the hotel's website. So it has to use the multiple tools that are available, that you give it to the agentic AI. So it should make a decision of which tool to use based on your input and what are the tools available for it to use.
that input is our query, right?
Yes. Yeah, input is your query.
I'm good.
Okay. All right. So I'm going back to the our Google Colab notebook, and then I'm using this platform or the framework called Phidata. Okay. So basically, what is Phidata? It's a framework for building multimodal agents and workflows. Okay. So build agents with memory, knowledge, tools, reasoning, build team of agents that can work together to solve problems, interact with your agents and workflows using a beautiful agent UI. So I'm not going to do the UI here, but at least through the code we will do it. UI we will go with other framework I will show you. Same thing, there's a LangGraph that I talked about. So LangGraph is also the same thing, framework for building agentic and multi-agent applications. Okay, so it's a graphical way of connecting nodes and creating that. Um, these are all different language now. And then there is so Crew AI, basically from deep learning AI. So Crew AI is also one of the leading multi-agent platform where you can create my agentic AI in this platform. Okay, so this is also famous, and then they collaborating with NVIDIA to create this platform. Okay, so basically Phidata. Again, we have importing the library Phidata. OpenAI we are using for the LLM. DuckDuckGo search is a tool for searching the internet. I think you must have heard about DuckDuckGo. It's one of the tools that you can use to do the search, just like Google search, right? So same thing, it's a DuckDuckGo search that can be used as a search engine in any of your applications. In the UI, they get it as a widget, but here you can get it as a library. And then I have Yahoo Finance. Y Finance is again another library which will give you the research about the stocks and everything, that information that you want to get. So you can get from the Yahoo Finance. So I'm installing this DuckDuckGo search and Yahoo Finance. These are the two tools that I'm going to be using as part of my agent. Okay, so I create all the libraries here, and then from Phidata, Phi.agent, I'm importing an object or class called agent. OpenAI chat we know, and DuckDuckGo is the search engine. So basically agent and search. So I have to provide OpenAI key. So we go here, enable this OpenAI key we already have and use that OpenAI key. The LLM I'm using here. So when I'm creating agent, my first agent, so the model in the agent is GPT-4 I'm using, OpenAI chat GPT-4. Tools I'm giving DuckDuckGo, internet search tool. That is the tool I'm giving to this agent. So the agent can use this tool to get the information. Show tool calls. So in the output, we are asking it to show which tool the agent is using, because so this helps in the traceability when you want to see, hey, the pipeline has run, the application has run, and I've got the some response or didn't get response. But I want to go back and see what kind of decisions the agent is making. Is it making the right decisions or not? Is it using the right tools or not? Right. So let's say it said, give me some latest information, and it said, sorry, I don't have the information. And then when I go back and see, it is not using the tool for searching the internet, and it's just using the RAG. Since the RAG does not have that information, it's saying I don't have that information. So to do the traceability, this flag we can use show tool calls. Now agent dot print response. So I'm passing it this query, tell me about this image and give me the latest news about it. So I'm passing this link, this URL link. So this is the image. Okay. So this is the image link I'm passing to this agent, and I'm asking it to give me some response about this image and the latest news about it. See, I'm asking it, tell me about this image and give me the latest news. So my query has two parts to it. Okay. So when I run this, what happens is, so it says thinking and the planning phase, and then it says response. So here it says the image shows St. Mary's Basilica located in the main market square of Krakow, Poland, Gothic church, and all of this is information, right? From here to here, this is the information. Now, where is this information coming from? It is coming from the LLM itself. It's the brain, right? Then it says running DuckDuckGo news. So it used the DuckDuckGo search for the news, and the query it sent to the DuckDuckGo is this: St. Mary's Basilica, Krakow. Max results is 5. See, this is not the query we have sent, okay? The query we have sent is this. Now it has broken it down to two parts. The first part about tell me about this image, it has taken already from the information that it already has, GPT-4, and then it gave this information. Now the second part I said, give me the latest news about it. Then it said it has to go get the latest news. So then it used the tool called DuckDuckGo. It has the tool already. So it is using that tool, and query it has built on its own. So what query I need to pass to that tool? So it said query is St. Mary's Basilica, Krakow, and it is getting 5 results, max results that I need 5 from the website. Then it gave me 5, the URL links for the latest news for the St. Mary's Basilica. So you can actually go click and see whether those are valid things or not. So anal crumpet call, Krakow fact versus fiction, something, right? So these are the information that it returned, the agent returned. So these articles from the, so basically two things. One, it has understood the query and then said broken down, it has two parts. And then it has made a decision to use the description from whatever it knows, the knowledge. Then it has taken a decision that it has to use a internet tool to get the latest news, and what query it has to pass to the tool to get the information, right? So that is how the decision making of the agent. So any questions here other than the syntax? Don't worry about the syntax. Okay.
So Arun, basically this is the agent means we can call it as a bot system something, or is it different?
So see, bot, yeah, bot. See, bot means what? Bot is your front end or a system that can give you response. Yes, this entire thing you can call it a bot. So bot can be just the LLM. ChatGPT can be your bot. So, and organizations are already having taking the ChatGPT and on-prem installing it on their organization to use it, so that whatever information you put it in the ChatGPT does not go back on the internet to see everybody. Okay. But the limitation still remains. So whatever knowledge it has, it can respond from that knowledge only. Second thing, your bot can be a RAG. So front end, you chat the same thing, but in the back, it can be a RAG. It can answer from its knowledge, or it can get the RAG information back. And your chatbot can be an agentic AI, where see this thing can be just your chat. Your query, you can put it in the chat, and in the back, that query is passed to the agent instead of the LLM. So that agent will again use any of these models, tools, everything internally, and then gets you this response. So basically, that can also be a bot, but a bot doesn't mean that's just like ChatGPT, right? So internally, a bot can be anything. It can be just LLM, it can be a RAG, it can be agentic AI, it can be multi-model agentic AI, right? So anything. Now, even if you don't have a bot, if you can just deploy multi-agent AI to take instructions and do the perform the actions. Now, here we are only showing the intelligence of the agent to decide which tools to use based on your query. So that's what we are seeing. So there will be a lot more complex things that can be done with the agentic AI. Got it?
Yeah, good. Thank you.
Sure. Now, let's say I'm taking a step farther. I'm adding two tools here. So same agent, AI chat, DuckDuckGo for internet search, and Yahoo Finance tools for the research on finance related information. So first I create an agent. So I call it web agent. Okay. Search the web for information. This is the role. So we said an agent will have a role and a model to take a decision, work on it, and the tools it can have. So I'm giving it a DuckDuckGo tool for this agent to use. Instructions, I say always include sources. I'm asking it to give me what are the sources that you have used to decide or to show whatever you are showing that response, kind of. Show tool calls is thing guessing. Then I'm calling another agent, creating another agent called finance agent. Uh, Role is get financial data. That is the role for this financial agent. Model, I'm still using the same model. It's okay, I can use the same LLM model, but tools will be different. So tools here is Yahoo Finance tools. Use the stock price true, analyst recommendations true, company info true. So it's saying check for all of this information in the Yahoo Finance tools. Use tables to display data. So instructions, you're saying when you get information back, use the tabular format to display the data. Again, showed calls true and a marked out. So now these are two independent agents, just like we saw here, right? We said it can have multiple agents, agent one, agent two. Okay. So if we go back here, this is just one agent. This is the example that we just now have seen. One retrieval agent. We gave it, just the LLM and then one tool. So first thing it went to the LLM to get the information. So within the agent, whatever LLM, and the information from the web. Now we are seeing two agents, and then we don't have these agents here. So it's just like agent one, agent two, and then they have two different kind of tools. One is the web search and one is the Yahoo Finance. Okay. Now, if you come back here, then I'm creating this agent team. Okay, so what is the agent team? Agent team is this one. So this will talk to these two agents, right? So that's what I'm creating, agent team. I'm not using this LLM. I'm just straight away using the same LLM to send the response here. Okay. So this agent team is also an agent. Now, what is the team? What is the team members, or what does the team consist of for this agent team? One is the web agent that we created here, which can go and search on the web. Other is the finance agent that can go and search for the financial data in this. And then you can add another agent, say for email communication, you can create a Gmail that we saw, right? An agent which can talk to Gmail tool to send email or get information, kind of a thing. Always include sources, use tables to display data, instructions the same that we have sent here, the same instructions we are passing. But default, again, it can use the same instructions here. Show calls true, markdown true. Now, what am I asking for? I am asking summarize analyst recommendations and share the latest news for NVDA stream true. So I'm asking what are the analyst recommendations and the latest news for NVDA. So there are again two parts to this question. Let's see how it goes. So running, see here, it shows the agent. First, it is transferring the task to finance agent. Okay. Get the latest analyst recommendations for NVIDIA Corporation, NVDA. This is what it sent with the task description to finance agent. Expected output is summary of analyst recommendations, including ratings, price targets, consensus. Additional information is provide recent ratings and any changes in analyst options for NVIDIA. Okay. So all of this, it has generated what it needs to send to finance agent. Then there is created another task to web agent. Description says find the latest news. Output is the latest news articles, include publication date, sources. Focus on news from last few days to ensure relevance. So all of this it has automatically done, created on its own. Says I am trying to fetch data for NVIDIA Corporation. I will address this shortly. Meanwhile, here is a summary of the latest news related to NVIDIA. So it gave latest news thing here. I will now attempt to retrieve again analyst recommendation. So somehow it had an issue here. So briefly, it stopped this. It says, okay, meanwhile, let me go and do the other task. Right? So we are not able to do one task. There are some issues with it. So we put it on hold. And then there is another task I need to do. So I'll go and do the task meanwhile. So it went in and did the latest news and then came back and then tried again second time to get the finance agent recommendations. So it gave in the tabular format we asked for analyst recommendations, what is current, buy, hold, sell, strong sell, right? 1 month ago, 3 months ago, current, all of this. Strong buy 59 analyst, slight decrease in buy ratings over the past 3 months, continued. So all of these are latest news.
Where's my money?
I don't know. It should be in the bag, right?
Murli, can you be unmuted? Okay. Yeah, so this is how the agent is taking the decisions autonomously to use the tools to solve the problem that we have given. Okay.
So all these tools that we are adding, right?
Mm-hmm.
Are there any is there any way that we can figure out what tools can be used as agents? Like which?
Yeah. So basically, these are just the Python libraries. Okay. It depends on which platform you are using. And then if you go to any platform, they'll tell you what are all the tools that are available to use with that platform. Okay. And you can also create your own tools. It's not like you have to use these tools. So how do you create your own tools is basically some frameworks allow you to use as functions. Let's say you want to write a SQL function, okay, or you want to have a Python library that can scrape any website data and give you information back. So you write that Python code, everything that will take the URL of any website. It does go scrape, does everything, and then return the response as a text or whatever, and create it as a function. And you can use that as a tool here, that function. So basically, it will go and call that function if it has the information about that function, what it does.
So how do we know if that fits our agent or not? So here we used DuckDuckGo for news agent, right?
Mm-hmm.
Yahoo Finance for finance agent.
Mm-hmm.
So how do we know, like?
So it's basically your use case, right? You are not building some random agentic AI application. So whatever you do, you only do to solve a business problem, correct? So what is my business problem? And then I will do based on that, what are the functions? So it's nothing but creating an application, say, okay, let's say this is a finance advisor application. What does the finance advisor application do? You have to use to write all of this, create all of this on your own, write code basically to do all of this. Go and search for, open the website, scrape the data, or log into their database, some API call. So you do an API call to that. They have some APIs, right? Yahoo Finance will have an APIs. So you send your query to the API, and then they send you the response, JSON. You pass the JSON, get the information out, and then publish it on the website or show it on the website on the query. The entire thing is just the same thing that you are creating it as a tool here. So for the agent to automatically take a decision what to call. So the entire application becomes a group of agents, right? So the
So
purpose of, say, travel agent, again, same thing. Yeah, go ahead.
any search engine can act as an agent, right? In that case.
As a tool, yes.
Okay.
Yeah, absolutely. So if we go here, for example, we are coming here, but since you asked, I'm saying, so you look at the tools, your Bing search
Yeah.
can be a tool, DuckDuckGo search can be a tool, Exa search can be a tool, Google search can be a tool, right? Python REPL, you can write your own Python function and create it as a tool. So you just give it some input. You can write all the code you want there, a Python script, and then that gives you a response. That's a black box for the agent. You just tell the agent, hey, in this scenarios or whatever, using the prompt or in the prompt or however information, that this there is a Python function called this that can be that can achieve these things. So you can use it for this purpose. So the agent should have the information what each tool does. So then it can make a decision when to call it, right? And then you have Wikidata, Wikipedia, Yahoo Finance, right? See here, that is the Yahoo Finance tool. So these are some of the available tools here. As we say, right, as it matures, people will add hundreds and thousands of tools. Or once you say it's an open source, like Python REPL, right? Python functions, Python tools. Any library can be used as a tool. Any function can be used as a tool. Okay. Okay. Any other questions? Okay, so this is the one of the agent ways of creating agentic AI using PyData. PyData is the platform for creating um, the agentic AI, as I said. So there are so many of them. Just like that, say, let's see what we have. Another one is LangFlow. Okay. Uh, so as we have seen here, LangFlow, we have LangFlow. Let's go here. So basically, this is still in preview. So sometimes it acts weird, but that's fine. We can just DataStax LangFlow is in public review. This is from DataStax. Basically, same ones who had the Cassandra. Now they build Astra DB on top of same Cassandra, which is the vector database we looked at earlier, right? Astra DB. So that is the same thing that from DataStax. So they have come up with this UI based flow, just like your draw.io or the Lucid chart, where you can drag and drop components to create a agentic AI. Okay. So Anshu, are you good? I haven't heard. Are you there? Any questions so far? Raju, any questions?
No from my end.
Okay, that's fine. So now if we look at this framework, one of the framework is basically your LangFlow. All of these things like message query that you put, agents you create, tools you create, all of this to build this RAG application or the agentic AI pipeline, they have given this UI where you have all of these components where you can drag and drop and configure. Okay. Now, so if you see here, inputs, basically what you give, you provide your text input. Okay. Output is the response, text output or chat output, what you want to use. Prompts is basically your prompt from the input you take and augment it with RAG or retrieval and all of that. So for that, you use the prompt. Then data. So what kind of data you want to provide? So for example, we were doing file uploads for the RAG to build. So, or you can use SQL query to pull the data, or you can use URL, webhook, directory, API request to pull the data into your pipeline. So these are all available. Then models, basically your LLM model, okay, wherever you want to use it as an LLM to process your response. You can use any of these, basically your Amazon, Bedrock, Anthropic, OpenAI, Cohere, DeepSeek, Google Generative AI. They've already added DeepSeek here. Grok, Hugging Face, all of this, NVIDIA, Mistral, OpenAI. So all of this you can use as your LLMs. Then comes your vector stores. We have worked with this, right? Cassandra, DB, Graph, Chroma, Couchbase, Elastic, Feist, MongoDB, PG Vector, Pinecone, VV8. So all of these are your vector databases if you want to use. Embedding models, if you want to generate embeddings before you put into vector database, you can use all of these models to generate the embeddings. Now here is, you guys able to hear me? Or did you lose me?
Yes.
Okay. So you have agent. So you can create an agent here and then provide all the inputs that is needed, required configurations. So for memory, we talked about, right? So agent will have a memory. So you can drag and drop. You can use one of these databases for caching, the memory. So we know already Redis and Mem0 people use for, caching data. So you can use any of these to cache the request response that is coming from agents, multiple agents within the agentic AI for the memory within the application. Tools is what we have been seeing. All of these tools are as of now available, but you can add more. continue to use this, or you can add more tools, what you want. I'm not sure what, so logic also you can put based on the conditionals you can put to say verify. Actually, you can also make the decision if you don't want to leave it to the LLM, or make LLM say, for example, categorize, and then based on the category, you can do if else statements and then pass it to different agents or different LLMs to do some of the operations. So we'll not explore that now, but that is the logic. All of this are just the helpers. I don't know what that is. But anyways, so these are the main components that you need to build an agentic AI. Okay. Now here I have the same RAG agentic AI. Okay. So there are two parts, right? First, to build the database with the information. So what I'm using here, I will expand this part first. See this part here, this part is disconnected. This is not connected to this picture here. Okay, these two are separate things, right? So this is the prep data. Remember in the RAG, what did you do? First, you have to read the file, chunk, split, embeddings, and then put vector database, right? Remember that?
Yes.
So the same thing here. Now, the first part is the file. What is the file here? File comes in the data. Okay. So this is the file that we put, and it has a file path. So you can upload a file here, any file that you want to, and then that file will be uploaded in the memory. Okay. Then you can connect this file to a split text. Split text is your go here. I think it's processing. Yeah, in the processing, you have split, parse, JSON cleaner, filter data, values, whatever you want to do. These are all still, I think, in development, beta versions. They are adding, the entire thing is still new. So there's just adding all of these things. Basically, we are almost on the verge of like moving from this kind of interfaces to this kind of interface, visual interfaces from the code. So you're just getting started, but there are a lot of, I think Crew AI is leading in that, which is progressing. So basically, yeah, so processing, you do split text, same thing that we used to do for RAG. You can give chunk size here in the configuration, chunk overlap 200, any separator you want to give, and these chunks you will pass out. So now if you see here, okay, now let's go, and if you see code, so you can also see once you drag and drop what kind of code it is generated. So it, in the back end, right, underlying, it has to execute code only, right? Even though front end it will put an image, all they're doing is based on the widget, they automatically generate the code behind. That's it. So it says character text splitter, and then it has a class, display name, and all of this icon, this one, name, handle input. So here int input, chunk overlap is one input, 200. Int input, chunk size is 1000, right? Separator, we have not given any separator, so it is taken default as new line. And output is chunk name, method, data frame. So output is a data frame that comes. It has defined a function, docs to data, split text, all of this processing that it need, it is to do to slice the text into a data frame and then return data. Remember, we have written all of this docs, splitter documents, and then return docs and all of that. So same thing it generates based on the widget that you put in. So whatever is the output data frame, now that you are connecting to a vector database. So AstraDB, we are taking from the vector databases here.
We have to embed these chunks, right?
Yes, you have to. I will show you what. So basically, when you take this vector database, okay, you can use a vector database or so this DS Astra DB, right? This is the vector database. So you can use this DS Astra DB. What it does is it will automatically connect you to the vector store. See here, it says database, explore data. You can automatically, if you click this, it will automatically take you to your Astra DB vector database. Remember we went there. So it is, these two are connected because these two are from the same company. It is already linked to it. So here you go here, create your database, create your collection. Okay. And then you can associate that database here. First thing you have to do is provide a Astra DB key. So whatever database key you generate here, there will be I think we have seen that earlier to connect to a database. So you will have which one? It's all cuisines. So go back here, all cuisines, and endpoint. So generate token, right? So if you generate token and use that token here. Okay, use that token to define this variable Astra DB key, and then you can put the key value here. So click, if you go here, it will give you add variable, add new variable, and then you can just put the key name, make it credential, put key name, and that value, whatever key that you see here generated, get that key and put it here, and just save the variable. So that will be available to select. So you can select just the key name here. So it will automatically take that value. So now, once you select the key, it will give you all the databases that you have created in this here. See here it shows, are you able to see? So all cuisines is the database. World cuisines is another database which says is in maintenance. So if you see here, it says, if you go here, because we have not used it, it's gone into maintenance. All cuisines is one, world cuisines is one, two databases. It will show you, you can select either of the database. So we have selected all cuisines here. And once you do that, it will give you an, what happened? Collection. I don't know, for some reason it's not. Able to connect, right? Okay, I don't know, maybe so there are two collections here, cuisines collection and my cuisines. So I think it should be able to see. I don't know why it's not able to. We'll see. We'll look into it. DB query. Okay. So we will check that. But basically, so when you do that, there is an option called embedding model. So when you're writing to database, you can choose to have your own embeddings. So you can create an embedding model from there, drag and drop embedding models, and then select an embedding model from this and give the OpenAI key because you're using OpenAI key embedding, and then connect this embeddings to this embedding model. So it will say this vector database embedding model. It will go and read, okay, this is the embedding model I have to use, and this is the key that I have to use to get this embeddings from here. And the data is coming from here, chunks, whatever chunks, you go and connect to the ingest data. So it will take this ingest data, use this embedding model, and write it to this vector database. So that's all happening here in this part. Okay. So any questions on this? No, this component has issues getting collection, but if I create a collection, it will take time to add that, to create that collection. "27 records, cuisines collection." See here, I have loaded that data from the same. When you run this, it will automatically load the data into this collection. So this is the collection. These are all the chunks that it has loaded from the cuisines folder. So I think you guys remember. Where is that? 1 second, let me open that. Zines should be here. No. Just 1 second. Okay. So this is the one. So in 20 international recipes, so this is the document that we have used to load that. Okay. So you can see that yakisoba, chicken, whatever. So that is what we have used here. It should be here somewhere if you want to see the content. I don't know. Okay, it should be here in one of these chunks, that data. Okay. 20 is international. See here, yakisoba chicken. Yeah. So this is the first chunk that it has written here. And this is the ID, and this is the vector that it has generated. Now, this part we have seen, so that's fine, loading the data. Now, let's look at how you do the agentic AI. So what I'm doing here is, I'm creating, so we'll come back from here. If you see, so I'm creating an agent which says can have the tool set. So the tool for this is a tool set, and all of these are the tools in the tool set. So what are the tools that we have? One is the OpenAI agent, LLM, and one tool is, what is the tool that we have given? Wikipedia API. Okay. So what is the Wikipedia API here? So if we go back, why is it behaving like this? Okay. So let's see. We talked about tools right here. So one tool I have used is the Wikipedia API. So this Wikipedia I have used as one tool. So if I go here, Wikipedia, I want number of results only one. Okay. And input. So what is the input? Uh-oh. So the input is basically the user message. So chat input. I'm taking this here. So connecting Wikipedia input to this. Okay. So the chart input is going to the Wikipedia input, and whatever response it gets, it will be delivered back using the tool. This is the tool of the agent. So the agent will receive the response as part of the tool, right? So that is one tool. The second tool here is calculator. I used again the same input from the user, chat input here. I know it's little kind of scrambled, but look at this. So this input here, the same input, now is going to calculator, and one is going to Wikipedia. Okay. And the other one here is basically your RAG, AstraDB, OpenAI embedding. It can go to AstraDB and get the data message, and the same tool set you can provide here. So this is the tool set, the prompt. Where does it go? I think some of the connections are broken here. Let me see. So we'll go here. Put. So this is the basically the RAG. If you use the user input, the question, it can use this message to get the response from the RAG and provide the results, the prompt message to the agent with the results here. So basically we have a calculator, we have Wikipedia API, and then we have our response from this RAG application. Okay. Now, the RAG application, how we built internal RAG is the same message, input message that goes to prompt. So the prompt will use this data to message, and this is getting data from search results from AstraDB and the OpenAI embedding it uses to get the information. Okay. I think these are all refreshed. I don't lost some connection here. Okay. So this connection is not visible here after the upgrade. So recent upgrade. we will check that. But yeah, so this is the complete logic that we have. Okay. Now, once you build this, you can go and check your output thing build here. There might be some errors because it's not working, the file component. But you can see here, so when I give the input, then just say Amravati. Okay. Now what it has executed, right? So input, so it has used the tool called Wikipedia. Okay. And then from the Wikipedia, whatever the page summary we have got, it is returning that page summary here. And that is sent to the LLM, which gives you this output. Okay. Now, if you use this Telugu movies released in January 2025, it says I currently do not have access to future data because we have not given the internet search to it. So I recommend searching entertainment news websites and all of that. If you go back and search, so here, see if I run this, what is the square root of 47? Okay, so this is different search thing. Then it says executed calculator. So it's using the calculator tool to solve this problem. What is the square root of 47? Now here, expression, it's sent as input, square root of 47. It is executing calculator, as this sent this as an expression. You got the response, and that is the response that is displayed. Okay. So basically, the agent makes the decision based on the input as to which tool it has to use. Okay. So this had a recent upgrade. So there is some configuration issue. It's not able to connect to the AstraDB. But that's the results that we can see from the previous executions. So based on the input, it will decide which tool it has to use. And if it does not get any information based on all of that, so it would say, I'm not able to get any of the information. So this is from the RAG. You say, give me the recipe for this. It will go and get from the RAG application, that file that we have just put it. Okay. Then if you say Wikipedia, we use this. So it will say list of highest grossing Telugu films, whatever it got. This is the information that it is getting. But then the output, it said, I could not find specific information for January 2025. Though the Wikipedia sent you some information on this because that's the only tool available for it. But when it went through all of this, it didn't find any information related to 2025. So the LLM then said it could not find the specific information. Instead of just, so that's why we said, right, whatever the agent, the information is coming back, we are again passing it through another LLM to see if the results are correct as per the query or not. So when it read this information coming back from Wikipedia for this query that it used the Wikipedia tool, then it said this information is not correct. So it did not give that information. Instead, it said, I don't have the specific information for this. Okay. So that's how you build the UI components. But again, this is still in preview, so there are some issues with it, with all the this framework. So that's why we have explored the agents based on the code for now. So agents, but you can still try to build a new one. It should work based on the same components that you have. So simple components, I think basically it's like using this Astra DB thing that you want. Again, if you have any other vector database, you can still go, you can still try using that vector database like Cohere or Chroma or whatever. If it is available here, you can drag and drop and try to use that. Vector stores. I have Chroma DB. Put it here. Let me take this out. So I'm connecting to Chroma DB here. Just for example. Where does this chunks go? Chunks go to ingest data. Okay. Embeddings, you don't need Chroma DB embeddings. Collection name is LangFlow. It will automatically taking. So let's take this embeddings here, connect to embedding here. Okay. So this is using this embeddings. This is using this ingest data, and then search results, data frame kind of a thing. So if you use this, just this part, and so let's say update the file, additional recipes, open. So this is the file. Now if I run this here, okay, see Chroma DB built successfully. So the data should be in the Chroma DB. Somewhere it must have stored. We don't know where, because we don't have its directory, right? Simple directory. Now let's say search query. Let's see if this works. I will just say Saba chicken and then run this. Just writing to the database, but we are not able to see that, I believe. Content. Okay, see here, output. So it is able to do the embedding and write it here in the Chroma DB. So as the same thing, basically you took the file, split chunks, embeddings you all kept same. You just replaced the Astra DB with Chroma DB here. Okay. Then you can use the same Chroma DB and collection name LangFlow here to get the search results for this. Or you can use any of these vector databases, whichever is easiest. Okay. All right. So that's what I want to show, how to connect these components in the UI. Just give it a try. There will be some open source or some of the resources available online, and you can explore this further. But again, so this is how the embeddings works, the components works in the visual interface for the agentic AI. I will publish this notebook. You can use this and you can complete this. Okay. So, and again, so this is the completes the boot camp, giving you the foundation to explore the AI things. But then there will be some bonus sessions in the future as and when we explore more frameworks. I will be scheduling some demos, free demos. You'll all, I'll invite you all, whoever is interested and available can join exploring these kind of frameworks going forward. There will be few sessions, probably using either QAI or LangWatch, or some monitoring or some building stuff using multi-agent, some use cases that we will develop. We can do the demos, and then you all can attend that. Okay, any questions, feedback? So you can share. I will stop recording for now.